So for this lesson, we're going to work on slope-intercept form. And I know we skipped 5.2. I can explain to you why we skipped 5.2 in class. The vocabulary is something you did hopefully before you started these notes. What I want to jump into is something called slope-intercept form of a linear equation. We will eventually make a graphic organizer of this and be able to find slope-intercept form. But for right now, I'm going to describe it. We're going to practice with it. Then we'll make the graphic organizer later because there's different forms we're going to graph. So the slope-intercept form of a linear equation of a non-vertical line is this form y equals mx plus b. When we write slope-intercept form, you will always have y equals. You will always have the letter y equals. M and b are the values that will change and be actual numbers. M represents the slope of the line. B, the constant, the number that's being added or subtracted on the end. We call that the y-intercept. That is the y value on the y-axis that the line intersects the y-axis. Okay, that's the point on the y-axis where the graph crosses the y-axis. And then this entire equation is in slope-intercept form. So we should kind of have a working idea of slope. The slope of this line being 4 means the slope is 4 over 1. So to count that slope, you go up 4, right 1. Okay? I want to keep that working definition of slope in our heads as we work through this. So in example 1, fairly simple example, what are the slope and y-intercept of the graph of y equals 5x minus 2? Well, if it's y equals mx plus b, m is 5, b is negative 2. So the slope is 5. The y-intercept, and I'll just abbreviate y-intercept, is negative 2. That's it. Be able to identify slope and y-intercept of a graph. For example 2, asking the same type of question, but just having you flip the question around. To write this in y equals mx plus b form, understanding if the slope is negative 4/5, that makes m negative 4/5. That makes b positive 7. So my equation is negative 4/5 x plus 7. That is my answer to this question. So understanding where the slope goes, where the y-intercept goes, we have to have a working definition of slope-intercept form before we can graph in slope-intercept form. So in example 3, writing an equation from a graph. So we have to pick out a few things here. We have to find the slope. We have to find the y-intercept. So the first thing, in my opinion, the easiest thing to find is the y-intercept. This graph is crossing the y-axis. Look at the graph at this point. It's crossing at a y value of 2. So my y-intercept is 2. Now slope can be a little bit trickier to find. We have to be able to count. The first thing I'm going to understand is that this slope must be negative. The line is decreasing from left to right. Past that, I pick 2 points and I count between them. I'm just going to pick that point. Points that fall on a nice intersection of 2, grid lines. So this goes down 2, right 2. So my rise over run, my change in y over change in x is negative 2 over 2. My slope is negative 1. So my equation is going to be y equals negative x plus 2. Negative x and negative 1x are the same thing. So either one would be acceptable in that situation. Okay? Example 4. I think that example 4 is the toughest example that I can show you in this lesson. Okay? Slope-intercept form, we need the slope m, we need the y-intercept b. So this is about remembering that slope formula. y2 minus y1 over x2 minus x1. So my slope is going to be negative 3 minus negative 2 over 1 minus 3, which is going to be negative 1 over negative 2, or 1/2. Okay? So we got the slope. Now, The hard part here is getting the y-intercept. We don't have a way of finding the y-intercept looking at a graph. If you could graph this, that would be great, but we don't have a graph available to us. So we've got to figure out how to do this. So it's about remembering y equals mx plus b. The x and y in y equals mx plus b represent any point that lies on this line. So I'm going to pick our point, 1, negative 3. 1 is x, negative 3 is y. So I'm going to substitute all my known values in to this equation and solve for b. So y is negative 3, y value of the point. We know slope is 1/2. We know x is 1. We don't know what b is yet. So we can solve this equation. Negative 3 equals 1/2 plus b. If I subtract 1/2 from both sides, that's going to be b is negative 3.5. So negative 3 and 1/2. So I'm going to write my equation in green so you can see it. It really pops out. Y equals 1/2 minus, or sorry, 1/2 x. Sorry, 1/2 x minus 3.5. That is my equation in slope-intercept form. Again, we will get practice on this. This is tough. We're going to go through more examples of these later on. So don't get discouraged if this was kind of confusing. We will go through more examples of this. Example 5. Graphing. I think graphing is just a little bit easier. It's about identifying, like we did in the earlier examples, the slope, the y-intercept. I always graph the y-intercept first. Crosses the y-axis at -1, so I'm going to draw a point at -1. And then I'm going to count my slope. Counting a slope of 2 means I go up 2, right 1 from my y-intercept. Up 2, right 1 will put me here. That's all I need to graph, but I'm very bad at drawing straight lines, so I'm going to count the slope a couple more times. Up 2, right 1. Up 2, right 1. On the flip side, I want you to know how to count slope to the right and slope to the left. If going to the right, it's up 2, right 1. Going to the left, it would be down 2, left 1, going the exact opposite direction. And it should make sense because this all forms a line. So just know how to count slope in 2 different directions as well. That's an important thing. Okay? Then the final example, I really want us to understand how to do examples like this, where we model using a function. So it says a plumber charges a $65 fee for repair plus $35 per hour. So I'm going to do a couple things here. First, I'm going to complete the table. 0 hours, he charges $65. 1 hour, 2 hours, 3 hours, 4 hours. He charges $35 per hour. So to get his charge for 1 hour of work, I would take 65 plus 35, which is 100. 100 plus 35 is 135. 135 plus 35 is 170. 170 plus 35 is 205, not 105, 205. So we should be able to pick out a rate of change from that situation. The rate of change in this situation, 35. It's a rate, $35 per hour, 2 quantities that are changing. Okay? He charges a $65 fee. This point with an x value of 0 is always the y-intercept. Sometimes I call that a starting point. 65 starts with $65. So my equation is y equals 35x plus 65. Sometimes I call this a starting value. Okay? So to graph this, pretty easy. We've got all the points. So this is the cost. This is the hours or the time, whatever you want to call it. So I'm going to graph this using estimation. 65, exactly 100, 135, 170, and then 205. So not a perfect line. And actually, I shouldn't have drawn a line there because this technically is a discrete function. But you know what? He could work half an hour. Maybe he charges you by that fractional hour. But that's one of the skills I really want us to build today and work through examples of modeling with functions. So you're probably ready for the practice by now.